All right, question number 6. We have annual interest on a $19,000 investment exceeds the interest earned. So it's saying it's more than the interest that we earned on a $15,000 investment by $474. The $19,000 is invested at 0.6% higher rate than the interest of the $15,000 investment. What is the interest rate of each investment? Okay, so we're looking for the interest rate. This one is going to be using the simple interest formula, which is I equals PRT. And we don't need T because T is equal to 1. We're just dealing with 1 year. So we're going to simplify this equation to just I equals PR. So we have two different interest scenarios going on. So if I were to compute or write the formula for the interest rate of the $19,000 investment, the amount of interest earned, so I would be equal to the principal, which is the $19,000, times the interest rate, and it said it's just 0.6 higher than that of the $15,000. So all I know is R, which we're going to call R, is the rate at the 1,500 investment. So R is going to be that rate plus it is 0.06%. So as a decimal point, 0.006 higher. So the rate of this one is 0.6%, which is 0.006 higher. So if I add this together or multiply this together, that will give me the amount of interest earned. Okay, the other equation, it says that the interest earned on that was, if I added this 474, this one, okay, this $19,000 investment is more than this one by 474. So if I just added the 474 to this interest, it would give me the same. Okay, so we're saying that, okay, I have this amount invested, I equals the 15,000 times this interest rate. Okay, but these two would be equal if I just added 474 more. Okay, because it says this one is more by 474. So this makes these two equations equal. Now the way that they're set up is going to be really actually, it needs to be on this side. The total interest is going to be 474 more. So I need to add the 474 here. So I have my interest rate plus the 474. That will give me the amount earned. So the way this problem is set up, we want to use substitution. So this, not interest, but the amount earned from the interest is now the same as the amount earned from this interest when I add this difference. And we can substitute for I and set these two equal, and then we can solve. So we will have 19,000 times the R plus 0.006 equals the 15,000 R plus the 474. And we're going to distribute the 19,000. Okay, this has been a recurring practice, the distributing. And we'll get 19,000 R. And then when we multiply that times 0.06, let's see what we get. So we get 19,000 times 0.006. We get 114. This equals to the 15,000 R plus the 474. Okay, so I'm going to collect like terms. The R terms with the interest rate, we're going to subtract the 15,000 R from both sides. And the positive and negative 15,000 R will cancel. And subtract here, we get 4,000 R plus 114 equals 474. And then if we subtract 114 from both sides, this leaves us with 4,000 R equals, and this looks like 360. And lastly, if we divide both sides by 4,000, we will end up with R, the interest rate, is 360 divided by 4,000, which is 0.9. So this is the interest rate as a decimal. Okay? The computer is asking for the interest rate as a percent. So in order to convert this from decimal to percent, we multiply by 100, or you convert by moving the decimal place 2 places to the right. So the interest rate R is equal to 9% by moving it 2 places to the right. So this is the interest rate, and we labeled R up here, the rate at 1,500, so 15,000. So 9% is the amount, or the interest rate at the 15,000, and the 1,900% interest rate was 0.6% more. So once I have this as a percentage, I just need the 9%, okay, plus the, I can't see that, the 9% plus the 0.6%, and then that will give us 9.6%. So one was at 9% and one was at 9.6%. So the bigger one was at 9.6 and the smaller one was at 9.